Everybody. So today we have a stream. It will be a long format, first long format and first stream at this channel. And we will create a full example of workflow during final element analysis of one of this CNC machine. So this CNC machine created by my friend from CNC house. If you want to repeat all things that I do by your own, you can go to his site, CNC house, and go to the 3D model part, and you can open one of the CNC model and do it by yourself. But in most cases, you can open any example of CNC machine from GrabCAD, for example, and you will have something like that. Not all process will be the same, but it will look very, very similar. I want to say thank you to Software Engineering Group. It's a Ukrainian reseller of Ansys products, so I will do all my work in Ansys Mechanical, in Discovery, Ansys, and so on. And I can say that a lot of things that I do today explained by two videos. First, it's very short, it's 1 minute all, about why we need to simplify model, and second, it's video more than 30 minutes, but it explains not only why, but how to simplify and how to convert your geometric model from mechanical design to good geometry for finite element analysis. So this is model, 3D model of all CNC machine. Today we will work with the smallest. It's called Mosquito. So first of all, that I need to show, it's something like this. Just a moment. Here our 3D model in Ansys. We import that and we mesh that. But with default settings of meshing parameters and so on, we will have some problems. We have several objects that not meshed. For example, most of cases are meshed, but this one mesh failed, as we see. Also, we see the main beam of portal is also was not meshed. We see mesh, but it's failed because he can't create mesh, and he stopped. So also we have also two beams that's also not meshed, as we see. And importing of this geometry are not very long, about a couple minutes. We will see it later. Also, I can say that mesh in about 10 to 15 minutes. We need to wait to create mesh. And the size of this mesh are about 1.2 million of nodes and 700 of thousand of elements. It's not a very big mesh, but you need about 20-30 gigabytes of RAM to create this mesh to solve this model. So it can be some problem for people who doesn't have a very powerful computer with a lot of RAM. That's the first things. Second things that we, as I say earlier, doesn't have mesh on all parts. So when we will try to do some changes, when we try to apply some preferences and methods to these parts for creating mesh, we will spend some time and we will create mesh about 1.5 millions or even 2 millions of nodes. And then we need much more powerful computer with much more mesh. For example, about 60 gigabytes of RAM, and the time that we need to solve this task, it's about not 15 minutes, but 30 minutes, 40 minutes, something like that. And we need to do several approaches, several steps for creating mesh. All this step will take some time and not 5 minutes. So if we will try to create a mesh on this model, we will spend a couple hours to create mesh and then to solve. And we have very problematic mesh. It's not accurate. It has small elements and big elements near each other. It has elements. Sorry, it's my PI assistant. We have elements with a very big problem with quality. It's the quality of our mesh. And as we see, good mesh it's about 0.8, maybe 0.6. So all these elements are not very good, and less our quality, the worse element we have. And as you see, the 80% of our model, the 80% of our model are not so good as we want, and elements present in all places of our model. So we don't get a good mesh with automatical mission preference. And sorry. In most cases, we can obtain not accurate result. So we need to do some changes, even if we don't want. And we will open this model. We will do some changes. We will simplify the geometry, and you will see full scale process from a mechanical design geometry to first result. I am sorry for my English and for some problems with pronouncing and so, because English is not my native language, and when I speak, I'm not very comfortable. Also, you can hear some different and strange sounds, not only from FEArytales system, but from airstrike hazard and some bombs and shells. Sorry, with Ukraine, Kharkov, and Russia is bombing our city. So let's try and let's look what we'll have in the result. Just a moment. I try to see, does we have a dream? Does we have any user? Okay. Someone's here. You can say hello to community. So let's talk about the small. We have 1, 2, 3, 4, 5 3D model, and step file with all this model about will be about 300 of megabytes. Full model in Discovery or Space Plane will have more than half of gigabytes, and it's a lot of time to open it. So we will work with not all models, but with the smallest one. It's about 30 megabytes. It's open much faster, and so let's do it from the beginning. First of all, we need to start our workbench. We start it from Start menu. To wait some time. After that, we can add a static structural analysis from the toolbox, and that's all we need. Just a moment. Here, our Ansys Workbench. This is our workflow where we create a pipeline of our process, simulation process. So we need a static structure. We add it to workflow list. Also, we need to save our project. Just a moment. I open files that we need, and here we say just a moment, name CNC mouse heater, something like that. I have no problem using this, as you see, so something like that. Do we have any new messages in chat? No, we haven't. Okay. So we need to add geometry, and with left mouse button we can import geometry. It's our step file. We will not create mesh for the current moment because it will be about 10-15 minutes. So we do something another. We already show how will mesh look like in basic variants, in variant by default. So we open our geometry with Discovery. It doesn't have license for space claim. It worked not properly. So we will open in Discovery. Discovery have similar possibility and similar features with space claim. It's very affordable and a good CAD system for kind of specialist because it's help in changing and simplifying any kind of geometry from any type of software, CAD software. And it has some special in with space claim. It has some difference in interface, but it work very similar. So I think that we can do all things that we want. I will show our assistant to you. Lots of just a moment. A lot of attention to himself. So something like that. Okay. This is our model. As you see, this model have a lot of details and only bolts and screws are absent. But threads in some parts are present. For example, we will have this part. Okay, this shaft doesn't have thread, but some other. Okay, this model have some simplification already. Let's do it. It must. So first of all, we need to explain that we have a lot of small cosmetic features that doesn't give any kind of information for our model, but it creates small features, small mesh. Just a moment, I will. Where it is? Here it is. Just a moment. If we will take a look here, we see that some simplification was made by Ansys by themselves, but not always, and a lot of small features create some small elements. Like this one, and so this features, this geometry object doesn't give any accuracy to our result. It creates only mesh, small mesh, and a big number of elements and nodes. So let's try to delete it. Okay. First of all, we need to understand that we can open geometry in a separate tab. We will locate this detail in our object browser. And we will take our component and open component in another tab. It's the parts we see, and it simplifies the process with our part and its simplification. This discovery and to discovery and split play are very simple process. So if you want to delete, for example, this round, this fillet, you can check it and press delete. Okay, maybe I need to turn on keyboard registration. Just a moment. We will. Okay. Now you will see what type of mouse button I press, what type of keyboard button I press. So we, for example, select this field, we press delete and it deletes. But sometimes it can be done by this simple way. For example, here we have this pocket, and if we take this face from this pocket and press delete, it doesn't work by this way because they have additional geometry, and we must to select them. But with this field, as you see, it tried to select all faces that tangent to each other. So it selects a lot of things that we don't need. Let's do it by other method. First of all, we can select this feature and we can just a moment, I will close chat, and as you see, oops. Yeah. Here we have advanced select. So when we select something, it tries to help the task. For example, we can select all constant face that constant to this. We can select duration, so it's as you see, it selects only face that we need, not any kind of additional. Else we can select with the same area and so on. Let's take a look what it gives to us. We select this one, select face with same area. Now we check depression. It doesn't want select both depression. Just a moment. Okay, not always work is the same time, but if we select this face, it creates additional depression. This one and this one. And we must have two depression here. One depression and two depression. I think that when we select face with same size, and then we must have two depression. In space plane it works something like that, but not always that's properly, so we need sometimes to do additional changes. But what we need to understand that if we take a look here, and we will see that how to create not on a clear place. It creates because this is plate from aluminum, and this is cut for creating geometry with ideal flatness. Because plate have very rough surface. So for our situation, for this case, more affordable variants will be not delete this depression in terms of discover and space plane, but move this phase according to this one. We will use our design tab. We will select this phase. We will check pool, and we will select this option up to, and then we select this phase. And as you see, he moved big surface to our small surface, and we doesn't have this small step. Here, so what we can see in results, we will have something like that. And this 1 or 2 millimeters doesn't give any changes to flexibility of our construction. So it doesn't change our result. But we will have better mesh than we have here. As you see, we try to create mesh this step. Also, we will use bonded contact in our static structural solution. So we don't need these holes for bolts, which must be here, because these bolts, when they tight, are glued this part to this extruded profile, and if we glue it by property but not by it's not do worse. So we will delete all this holes. What we need to do for delete all holes in one operation, as you see previously, we can select all these holes and delete, but we can select by other manner. We can select one, and then here in advanced selection with power, we can select all holes which are equal or less than 4.5 millimeters. As you see, if we select only equal, we don't select this small. If we select less than 4.5, we select all holes and can delete it with only one button. Okay, also we can do this with these fields. We select fields and we select all rounds. Let's change, for example, 5 here. And we select all fields, we delete them. And we simplify our geometry. We have less elements and nodes on this geometry. So that's very good. Here we have bearing and just a moment, let's create a section. I don't remember where is it. No. Have some difference with space claim, and I don't work for a long time with Discovery, so I try to find it. But just a moment. Page plane and clip with plane. Yeah, something like that. As we see, this all is technological. We doesn't need them in our geometry, so we also can delete them. And we will do it on our assembly. So we change one geometry, and second geometry doesn't change. A second example of this plate, because it's not equal plate. It has some difference in reasons that we also have a place for motor, for holding motor. So it's look very and very similar, but it's other part. As you see, that was a front panel, and this is the back panel. And open components in top, and we know what to do, so we will do it much faster. So we choose this face, we choose pull, we choose up to, select this face. Okay, now we choose all our holes by selecting one hole, and what a problem. Select all holes smaller than 4.5 millimeters. Let's select this fillet, say here 5 millimeters. Delete them. In the output model, forget to create home here. Okay, we will do it by ourselves. So we choose this one, we take pull and move it. Okay. And we have second plate, and it's more simple. We have more simple and accurate mesh. Accurate not in reason of mesh size, but in reason of mesh quantity. Also, we have a lot of additional side. It's just a moment. As you see, we have number of this part, and when we simplify one part, we will simplify all parts in assembly which similar to this one. But if some parts created with was created in original CAD system with pattern or mirror, that can be a more difficult situation. We sometimes need to do simplification process a couple times for all parts of array or pattern or mirror. I see in statistics that 2 people watching now. As I said previously, run not everybody, or hello, or morning. Please write something in chat to have possibility to see who is that. Okay, we have the bearing. It's model from producer of this linear element of linear motion, and this slide is there's a lot of small cells inside, and this, for example, is a plastic part. This part is steel. So real geometry look very similar, but for our simulation, it's not very interesting. This part more complex that we see, because inside of this parts we will have a lot of small spheres, a lot of small channel for this sphere for working as bearing and slider, and a lot of other different objects that are present in real life but absent in our reality, in our CAD geometry. So this model are simplified, but simplified not in a proper way for finite element solution. We can create in our finite element analysis here, we can create bonded contract, and in different ways, depending on what kind of simulation we need to create, we will use different methods. But in most cases, this geometry can be simplified as maximum as we want. So we will do that. And first of all, we delete all things that we don't need and create something new. We select this face, we create sketch, and we try to create sketch something like this. In reasons that we will glue this geometry to right strain, oops, vertical. Okay. Then we need to parallel this one to this one. Okay. So in reasons that we will do this part to our rail, all this geometry are not important. This geometry will be important only if we will try to simulate the form of this slider as it were in reality, with a lot of bearing balls, with a lot of objects, and so on. Okay. Something like that. Something like that. Constraint, we say parallel. This one to this one. This one to this one. Okay. And we choose all these faces what that created and extrude them to the end of our slide. But something I do not in proper way. Okay, we'll do it by another. This face and this face and this face create a mirror as in plane. See body with this geometry with this plane. Delete this geometry. Okay. Now I need to simplify our selects. Delete. So something like this. Split body with this surface and delete everything entire face. Okay. Delete this one. This. This one. Okay. Do some changes here. delete this geometry, delete this geometry. We have, oops, sorry, we have this one, this one, something like that. And we will delete the false. Okay, we simplify our slider. We need to create mirror with this place and create mirror of this part. I see that new geometry look not similar to previous version, but something like that, and it will be enough for strengths and for stiffness calculation. So let's go on. How we can, just a moment. Okay, as I say previously, these two objects are separate, as you see, this one and this one. And these two objects are simplified. We can do this simplification by two ways. For example, we can open one of this part and simplify it, but we can also locate in tree, and we can delete both of them. And now we can mirror our test part. So we create mirror. We say that we mirror your display, and we will mirror component. This one. Does work in proper way. Just a moment. Looks like it freeze. Okay, we'll wait for some time. But something is freezing. Phew. Okay, let's close and let's pray that Ansys save our work. Sometimes it happens. Oh, okay. I don't know what the problem. Let's save. And try to repeat. So we will some problem with mirroring components. With body no problem. With components, okay, ignore one component and now second. Okay, we do simplification. Let's work with the rails. We will open the rail. Here it is. Oh, ouch. Sorry, I don't came out of mirror. It's my fault. Yep, sometimes. Okay, while discovery is reason. The table. Please, please work faster. That's why sometimes you spend more time than you want. Sorry for that. If you have some question, you can write in chat, and I will try to answer it. It's almost unfreeze, but it's not Okay. 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 So, this is our rail. And we can open it in the new tab for more simple process. Now we can select this rail, locate in tree, and also open it in new tab. What we need to do is simplify this. Okay, we will delete this one. And let's convert it to a simple square object. Split body. This body with this surface. And let's both parts and with this surface. And also delete both of them. Okay, we have holes here, so it's like three faces. We open this one and select faces with the same area, and this is all our holes. We delete them, and we have rail for the stiffness calculation. If we need a stress calculation, it will be a big problem. For stiffness calculation, we do in a proper way. Okay, we create some features, but we have this one. We mirror all our components, so that's why we look not proper way, and that's why we fit. Okay, let's repeat with this one. Open component in tab. We also select all these features. We delete them, and now we create a split body. Select this one and select this face, and we control this face. And now we will delete all four corner by the one operation. Okay. We have additional part which we have to create by mirroring component. Okay, to me, it's my fault. discover ways for me speaking English and showing this thing very difficult, so I freeze too sometimes. Okay, now we must work with this object. We can list all holes. We'll delete all rows. Okay. That's my method, but as we see, we not delete all the problems. So what we can do, we can select this one. And here we can choose option select all parts, and it will be much longer situation, but as you see, something like that. It's a very powerful tool, as you see, but you need to be very accurate with it because it can select not only things that you need, but things that you don't need. And if you will delete it, you will delete a lot of information and geometry objects that you need in the completion. So don't use automatic tool without checking result. Now we need to wait. Okay, we did it, and see, we did all these fields. Sometimes they are not in a proper way. Just to see what is this thing. Okay, now let's work with this one, and we will do it in another way. We will activate this object in this tab. We not open in other tab. So first of all, we will work with this object. Select all those faces, delete them, select faces in area, delete them, and we can hide all others to see what we get. And we have two geometry population, and only to row is the faces. And that this one we can change, and we can leave in original black. Let's change to this geometry. Okay. Show E. And we have small problem. Yeah, because our geometry are bigger. Let's try to change it. We pull and we need to select this face and I remember how it worked in space claim, but can't understand how to do here. Okay, what we can say? We can say that we can this one. We can select the geometry. We can pull it. Oh, we can't pull because we work with NEMA 34. Sorry, it's my fault. Axis activate component command. Now we can work with all object. We pull this one, something like that. We will show all, for example, and up to this one. Okay. We simplify this one, and we need simplification of this clutch and those bearings. Let's do it. Select this one. In most cases, we don't need this clutch because it will rotate the shaft to change position of our x-axis. But we will not solve situation when we change position. So in this case, we can delete the geometry and it will not give any problem to us. I say clutch, it's called coupler slider. Okay, no problem. We will delete this one. And we will have something like that. Also, we need to open this one. Okay, open in Newton. We have two body. We need to select some structures. Faces with the same area, faces with the same area. Okay, we select this one. Sorry, it's hunting. Delete. Also, we can combine because we don't need to different geometry here. And what do we need to say? We need to delete all small features and objects. Okay, let's try it. Something like that, yeah. Delete, okay. Delete, okay. Please delete them. It's not very interesting to work in silence, so if you are watching this stream, please write something on the chat. It will show that you are not a robot. Proof you are not a robot. Something like that. So, delete them. Delete. Why you don't delete them? Ah, yeah. You can delete, and reason that you doesn't select all. Since it's my fault, I don't check situation. Okay, we don't need this one to delete. And all others are good. This one we will delete too. Delete. So something like in most cases we can simplify this geometry in very different ways, and we can delete lots of even just depending on our task. As one of the variants, you can see what I do. Okay, we can close that one, and we need to place parent here. So we need to select component, this component. We need to move. We need to just a moment, we will hide this geometry because it will not help us. Okay, we also select component, this one, which is move. We drag and drop to this surface. Now we select up to and select this case aluminium profile because it coincident with this face. And it's not coincident. So it's my fault. Okay, let's move this face to this one. Takes a pattern. That's what. Okay, now we have whole situation look properly. And here we have also problem. Yeah, we have also problem. Why? I think I know why, but it sounds very strange to me. Maybe I do some mistakes. But mistakes is result real flow, so it's not a problem that we have mistake. We only must have possibility to find it and to solve it. We have lots of different objects, as you see. Just a moment. We select the face, select a plane, we create a mid plane, and we clip with this. And as you see, we have bearing. We don't need all these objects. Let's leave that we need. We need this object, we need this object, and we need this object. Hide all others. Okay. And we here see that some of these objects are turned off in visualization, so that the objects that we don't need, and we can Swedish. Okay. What do we want to do now? We can change this one to this. We can change this one to this. Okay. This one, I don't understand what is it. Okay, let's delete them. And we can change this one to this. Okay. Now let's delete to this faces. Delete. Now it can delete. Why? Oh, it's one border. I understand. Okay, let's work in another way. So we up this one, and we up this face to this face. Okay, here, and this is very problem. To delete all those elements. Okay, now we select was called. Delete them. And we almost finish with the bottom of our CNC machine. There's only one problem left. Not only one. We have two problems. That's the first. Float it house. Open in your tab. And okay, it's not like that. Let's try to delete. Let's try to delete all other chamfers. All different chamfers with very wide range of face areas, so we need to create more intellectual rule to delete them or to do more dumb work as I do on this example. So we delete all of them. Just a moment. Yep. Also we need to do with this rolled ball screw. Open component in the tab. Very intellectual work, but is 60 to 80% of pair specialists. Let's try to do intellectual work face with the same area. Face with the area here we have 32. 100. Nope. Yep. All this feature. Okay. And we need to delete this one. Why it doesn't do it? Previous operation, I don't know. Okay, we create it. So and the last in the white bottom is a file aluminium extruded profile. Location 3. This one and this is second. And unfortunately, this is two different parts. So when we change one, we don't change second. So we delete one of them. We change one bottom. Okay, bottom to let's see. Select both of these faces. Power select and select this variant. And let's try. Just a moment. Nope. I don't want this. Better, but not all things that I want. Okay, it's nothing. Select this one. Face to the same area. Skdish. And we need to delete all those objects. Face with the same area. Delete. Okay. We create a much more simple variant of our aluminium profile. Yahoo! Let's close. Let's create a mirror plane. And let's create a mirror components. This one. Please work faster. I don't understand why it freezes on mirror component, but in some reason it freezes. Okay. With all things that we need with this part of parts. Something like that. Let's go to other. So y-axis is done. X-axis. Open in a new tab. Oh, okay. Um, Open component and tab, and let's try to do it faster. In another way. Bingo. Teach. Teach. Okay. Teach. Teach. Okay. Let's try to do it step by step. If you don't want to delete it in one step, let's delete it in couple. Teach. Something like that. Okay, let's take a look. How many objects are changed? Only two, unfortunately. We can copy and paste, but we will First of all, we need to change here. And now let's delete oops. Ouch, I hate it again. Ouch, I did it again. Productive baby. Okay. Up to this one. Okay. And this one we will change to this. It's It's as you see, I try to show different workflow of deleting and simplifying same geometry. So I do it in different ways, and you can see which way work, how different ways work. First of all, and second, you can see different variants and understand who are more productive and who are less productive. But sometimes more efficient and more productive variants can give some problem. So you need to know different ways, and it will be very useful for your work in the future. Okay. Okay. We will open this one. Just a moment. So this profile is already simplified. We don't need to do nothing with it. That's good. Also, we need to do something with this profile. Yeah, I see. Open component and tab. Oh, Ouch. Oh, it's a very big problem. It's facet geometry. It's not geometry. It's facet. I understand why a computer does not want to create. Yeah. Okay, let's try to fix this. Let's try to delete a more simple object. First of all, this one, this one, this one, this one. 5 faces. Power select. All rounds between 0 and, for example, 1 millimeters. Delete. Let's wait. So, waiting for it. Waiting for result. It will be havoc. Sometimes it's simple to redraw. Profile like that, because it's very bad. Yeah, so face a geometry in solid and solid regime. Please go faster. Already spent almost 2 hours. In most cases, task like this counting is 4 to 5, 6 hours. So I tried it with my best, but not Flash. Even Flash Gordon. Very interesting. How many cores did we use? And I think we used. That's cool. We use all cores. It's only one. That's cool. Yeah. Yeah. Let's try to do additional simplification. Select three those faces and delete. The main faces are not curved, it's flat, and we don't get a result which we want, unfortunately. So let's try to delete. I don't know what we get, but I hope we will result faster than in previous operation with a lot of fields. It's a 3 millimeters. Okay, let's delete that. Unfortunately, I can't turn on music because if I will turn music on and this music will be on a stream, we will get a denied permission to show this video to other people. So we work with only my voice. As something that is stream better. And I know that my voice can't do stream, but we get what we have. Something like that. Okay. So we delete all small features and we have only with and in most case I need to say that those objects can be useful when you screw the bolts here, but for construction stiffness it's not very so let's simple way we'll delete this object and simplify in a very simple way. So let's create a sketch. Hello, Discovery, answer to me. Okay. And first of all, I will cut the geometry from here to something like that, to here. That's the first moment. Second moment, I will do something like that here. In this place, we will go from this point to this point. Additionally, we do some changes here. And we add material here. We add material from this point to this point. Nope. Nope. We don't do that. We do. Sorry. We do something like that. And here we do the same. Okay. For example, and what we also have? We also have problem here. From this one to this one, and then we delete those geometric objects. So also we came from this point to this point. That will be good enough. Okay. Now what else can do? We also can do something like that, and we will say that these two lines are parallel, and these lines are parallel too. What's the problem? Just a moment. Parallel, this one and this one. Don't want. Can't understand why. This too. Okay. And what we will have here. So we work with this corner by two way. In this place, we delete in this way we add geometry. So something like that. After we read one, we will repeat it to this place. So let's select. And now we have a couple places. This place we will delete. We select all the subjects. We select the finish and we will cut. Please, 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 please. Work in a proper way. It's very important. Yeah. Okay. Save. Just for a case. Because I don't want Ansys crash. Now, and the work is the surface. See. So we have this, and we also pull it up to and put up to the face. Okay, it doesn't have problem only here, but we will fix them. We select the three face and delete. Yep, deleted, it's fixed. Here we have also variant, so we look like that. And now we will use this space and this space to add some geometry. up to, and this up to this face. Okay, for ouch, here you don't work in proper way, just a moment, up to, just a moment. It's a harding. Did we? Yep, we do. Here we have much more situation than we have before. We can also change it in variants like this. We can use spline tool, use this point, and this point, and this point. Ouch. Okay, and something like that we're going to do here. First point, second point, third point, and fifth point. Bumps. Ba-boom, big ba-boom. Why we don't do this situation when we have a lot of faces? It is that it will be much harder to ask to control which way will go this line. Does it cut or does it add? So we add material and now we cut them. Also, we can use not spline, but an arc by 3 point, so we can get more accurate result. Ouch. Let's we'll fix it. So here where the problem, and we must do something. Yeah. Face it. No, face it. It's not for this merge face. Yep, merge face can help us, but but not in a very good way. What do we can here? Okay. This is the place we have the only. Let's do from here to here. To here. To here and something like that. And we have fixed until ouch. Control, we need the control. Download the control key. Up to and now in ouch, and I lost control. Sorry. Close the door. Control key. If Dr. Martins will write his story about discovery, one of the person called not Hodder, but Focon, something like that. Okay, it's better job, but that's all I can say for now. We will delete this geometry and compensate that we delete both of those horns. We add some material. So we select to these faces and something like 1.5. 1.5. Okay. And something like that we will repeat. Select. Oh. Yeah. I want to pull it. No. Not 25. 1.5. Maximum 2 millimeters. Okay, I do something like that. Now I want to slice my geometry. Slice with mid-plane. I create this mid-plane. Here it is. I split this body with this one and delete these things. Okay, I delete the surface because I don't need it. And I mirror my body with this plane. And we have much simpler geometry. Ouch. So, this one we will fix. Yep, I forgot as English. This one we will fix in Ansys Workbench, so don't think that we forgot them. Okay, something like that. Do we need to delete this one? Nope, I don't want to delete because it do our construction worse. And also can add some rulets here because it's in geometry, but in most cases, all things that we do are mostly perfect. Cousin. So I think I close something. Yo, what I close? I don't do everything I want. I do only half. We have some additional work. It's very hard when you freeze more than your computer and software. Ouch, not space claim. Not space claim. Why space claim? Discovery. I will have an error with space claim. Not space claim. Ugh. You say discovery. You stuck in space claim. Dumb system. Yep. An error. And I tried to import original file. Ouch, just a moment. That's good that I press save. It's important. Let's, yeah. What I say, it's spend time to import geometry, but it opened with an error. I don't know how to fix it. I read a lot of information in the internet. I write to Ansys company and they send some information how to fix it, and it's not work. So we close this one and we'll try to open our DCO file from discovery. You even close for a long time. Yeah. Replace geometry with browse. Just a moment. Kamar DCO. Kamar in Ukraine and Russian language, it's mosquito in English. So, edit and discover. If it not open my geometry that I saved for the last time, I will stop the screen and start to scream for a long time. With the speed, I don't know. Will I finish before the shell strike or not? Open, open. Please open. In Ukrainian, I will say tormos. It's simple translation is brake, but I think it's not correct translation. We called in this way person who freeze all times. Ouch. No, it's not my geometry. You save to the document folder. Okay. Okay. Just a moment. We will fix it. It's not a problem. I say that it will start to scream, but it's not a problem. We can. Yep, I see it. Okay. Just a moment. Ouch. Replace geometry, browse, and here it is. It's a version from documents and settings. And let's open in Discovery. people who work very slow, think very slow, and work and think and speak with a lot of phrases, we called tormos. It's translated in English like break, simple break. And for my thoughts, I understand that models are complex, but tormos. If we would be more tolerant, we will say tormozatko. It's something like very young and very cute tormos. Very cute break. Sorry. Oh, yeah, that's better. That's better. Hmm. So, what should we do? Hello profile. Yeah. As a grade X axis. So we need to simplify those geometry. Okay, let's choose power select all runs, and we select only as this model, but we will search all bodies in our parts. Sorry, and delete. Okay, you see, we delete a lot of filaments. Now we need to choose this way, and something like that. And delete. Ouch. We will delete holes inside aluminum profile. It's not very good. It's not critical, but it's not very good. Hide. Yeah, here some small holes, and we delete it, unfortunately. But it's not critical, as I said previously. It's not good, but it's critical. Okay, we select to this hole. We will not select on all bodies because they will delete a lot of other things. Okay, we delete to these holes. We don't need them because we will glue our geometry here. What we can do also, we must simplify this rail locating tree. I don't remember, does discovery open component by the right way. So I do something like that. Okay, it's already simplified, as you see, because it doesn't have a lot of fillers here and have much more simple profile. But we will simplify it additionally. So we use split tool. We split. Split body, sorry. Split tool, but split body and something like that. And delete, and delete. In reason that this files was given by suppliers and for different type of rails, type of screws, bolts, shafts, profile, and so on. They give different geometry. So you have very similar object in a different place of your assembly, but they look very different. So okay, yeah, we do. Now we need to try this one. NEMA 34, open in new tab, and this we will pull to this face. Okay, and now we select those in the labs, and we will select this one. Face with the same area and delete them. Okay. We will close all parts that we don't need, and let's work with the other. I see the comment. Let's take a look. Just a moment. Can you suggest some video for learning CFD on an Ansys Fluent? First of all, I think that if you want to solve something, you need to solve not a software, you need to solve theory. You need to solve, not solve, you need to study. You need to study computational fluid dynamics, basis and theory, and you need to learn some theory about finite element analysis and finite volume. Method. That's the first. Second, on Ansys course, on Ansys, you can find Ansys.com, and on Ansys.com you can find a lot of learning material for all products. Ansys Academic Learning Resources, just a moment. And so here you can find free software for students, and Just a moment. Additional resources. Just a moment. I need to find some tutorials. No. It's not here. Just a moment. I will search and say maybe most probably free courses for students. Udemy. No, I want not Ansys student free academic. Just a moment. Just a moment. I will. Just a moment. I will search and I will. Oh, yeah. It's and talk about in a very popular format, so you can read, learn, and we don't have some course want, for example, learn physics. It's 80 and out customers, and if we'll take learn simulation, have IC courses and remember its model, we need to find it. Nope. Maybe I'm what I think. So we have instructions. No, we not instructions. We very strange to find 50 courses of fluid. I tried to find courses about fluid structures apart, and that's that's interesting and quite so. Here it is. A lot of courses about CFX, CFD, and fluid. I think it's most powerful and most useful number of courses for every people. Additionally, you can find a lot of courses on YouTube. Additionally, you can find a lot of courses on Udemy, but for me, had to choose which video and which courses are good for learning Fluent, because I don't know Fluent. I'm a specialist on computational mechanics, on fundamental analysis, and so on. So, with help of but very useful courses about Fluent. So we answer this question and return to our process, because it was good, but we need to finish them. Sounds like that. So we have a couple objects that we also need to simplify. This bearing, because it have a lot of balls, open component on top. You see, we have a lot of balls as in previous section. So I don't understand how it works, because it doesn't have hole. Okay, let's do by other. Hide others. Delete all these unneeded parts. And now we must do something like that. And we create a simplified version of bearing. Additionally, we need to delete this chamfers. My cat tried to say that we need to rest, but let's finish process. So it must have the hole, but it doesn't have. It's very interesting. Okay, we will change it. Open component on top. Draw the hole and change its size. So additionally, our assistants now start to blocking keyboard and hand with mouse as it like. He very like to block keyboard and hands during my work. It's very interesting to him, and I think maybe very comfortable. I don't know. Maybe he tried to say additional. A lot of variants. All variants can be right. So I don't. Ouch. This street will create a very problem for creating mesh. Number of bodies says that we also have big problem. Okay, we'll select those body. We hide all other body. And we will delete all bodies that we hide because we don't need them. Mechanical designers, when see how structural analysis and FEA analysis work with their model, when see what I delete something. Just a moment, we will do in another way. So when mechanical designers see how structural analysis specialist or FEA analysis specialist work with their models, they say a lot of bad words because they do a lot of create so detailed model with a lot of parts, with a lot of fillets, with a lot of holes and features and so on. And those dump finite element specialists delete all their work. And that's very sad for mechanical designer. But we need to say that mechanical designer also do dump work because you need to design your object. You need to design it, not to model. And modeling and designing process are not the same. When you design something, you need to create things that will work properly. And in most cases, geometry can't answer to you, can this object work properly or not? You can do this only with simulation. So before you do very detailed model, please create simplified model. Please check it. Give this model to FEA engineer, to stress engineer, to CFD engineer. Let them check this geometry and let them say, what did you need to do with this geometry? Maybe you need to send this geometry to trash and recycle bin. Maybe you need to do some changes. Do this some changes. Let them check your design. Additionally, and after that you will have good design, only after that create a detailed model. Something like that. Delete. Yep. We do some delete. What we can create additionally, we can use the same. Delete. Delete. Something dump. Freeze. I push the button, but they don't work. Maybe in reason that they don't want to work, maybe in reasons that I don't push button. It also can be. Okay. Something like that. Ouch. Delete. Delete. Thank you. So, and we create holes here. No. Not in this, but in this face. And create hole. Something like that. And the last we need to combine those and those one in one. Okay. I'd close something that I need. Maybe. Okay. X-axis and open component and tab. Okay, we almost finished process. We need to delete some mistakes that left from the previous work. We hide all different things. Oh, this one, we don't need this one, as I say previously. Locate 3, coupler slider, delete. Okay. Yeah, we need some additional things. We need to pull this diameter of this face to this face. Okay. Also, we need to pull this face to this face to create something like a bearing. No, you don't want it. Why? Just a moment. Up to this one. Okay. We create we almost simplify all our object. We need to check does we delete all holes here. Yes, we delete them. I also can delete this chamfer, but it's not small, so it doesn't give to us any kind of additional advantages. Only we will spend what we can do, we can pull these faces to this because this that you see was created by CNC for ideal jointing all elements like slider with this plate and so on. Just a moment. Not in the right way. Sorry. Pull this one to this one. Okay. And here we will do the same. We choose this face and pull it to this one. Now we have only 2 objects that we need to simplify. Delete. What the hell is this? And we will delete this small page to okay. So the last but not least during this Mhm. Ouch. God bless the person who create Control Z. It's very cool person that save a lot of people. This one, rollerball screw, component tab, okay, okay, done. So this one, this one. 4 faces, face with same area. Delete. Yep, we do it. The person who creates space claim, it's also cool person. It's not one person, but they're very cool. Direct modeling is a very powerful instrument and feature and tool and method and all the words that we can say. They have some restriction. They have some disadvantages, but they very cool for computational specialists. So we create something like that. And the last that we need to simplify, it's Z axis. And after that, we can create mesh. And this mesh will be less, much less than in the beginning of our video, of our stream. Question to all people who watch this video, not important on the stream, on as a saved video and so on. Level of English. Does it enough to understand what I say and what I doing now? Please write a comment. Okay. Open. We have some problem. We doesn't need this information just at all. We select them, we delete them because we don't need it. So that's a code. We also don't need this chamfer. And we need to nope. Sorry. split. Split. Where split? Clip plane. Sorry, not split, clip. Why I'm clipping? Because I know this, this kind of geometry will give very big problems, so we need to solve it. We pull this geometry. Maybe we pull this geometry to this one. So we have one body. Additionally, we will have about 60 millimeters. It will be for cutting material. We can not model a flute. We can create a remote force, but with flute we can control deformation of flute, and we can create stiffness of wall project, not only a CNC machine, but motor and flute additionally. So clip, okay. And now we need to check to select all this. Why it's not great? Select. Okay, let's try to do it another way. 3 faces. Faces with bingo. So ouch. Not home button, but delete button. Something like that. It's our motor plus flute. Okay, let's open this one. Power select. We need to select all rounds less than 2 millimeters. We delete them, and that's good. And we have, can we delete this one? Just interesting. No. We can delete them. And here we can. Okay. Let's try to let's create something like that. Pull. To this surface. And why it's not creating? Add material to this. Okay, this whole big, this whole we will delete. For simplifying mesh, this whole will not give us a problem because it's in flat surface, and we will create flat mesh. But this and this also will give a problem to us, and we will search why is this object are not the same as this object. Okay. No. This one, this one, this one, and this one we will delete. And here we will not solve this problem. In reason, we will see how the mesh will differ in this place. Okay. Let's hide the object that we already do. Open. So this one pull to this surface. Okay. Delete all. Delete all. Delete all. False. Okay. And now we can select this one. As I see, Discovery is also tired, and we need to rest. It's almost done, so please be patient. It's not very long time. And don't delete them. Yeah, I don't delete. Wouldn't delete. Something like that. Hi. Open this object. Open this part. And delete all poles. That less than 6 millimeters. Okay. And delete all rounds that less than 10 millimeters. It's not important for our calculation, so we can delete them. Okay. Hide. Component, open component. So this pocket are formatted with sliders. So we will move all the spaces to this one. Additionally, we will delete all fillets. Additionally, we will delete all this. Bam, bam, bam. Pulse less and paste with the same area. Delete. Additionally, this place is pocket 2, so we change position of this face to this one. Okay. Okay. Additionally, we can move this face to this point. It will not do any changes in stiffness, but will simplify meshing. We will change in one place, something like that, and we will see the difference between here and here. So we doesn't need this geometry, and we need this geometry. All the same, change this one to this place. Here we have a lot of features that already cut it. We need to change position of this to faces, and that's all. And now we have a big problem with number of fillets. Something like that. Okay. Holes less than 6 millimeters and paste with the same area. And delete. Yeah. Hey. Nope. This one will stay. It's not very good, but let it be. I'm not Beatles, but let it be. Let it be. Let it be. I will not sing because it will be horrible. Hide object. So we have two rails. open component. Okay. I don't understand why we have something like that, but it's not very important. Split body. As we done in a previous situation, we split here with control split here and delete all materials that we don't need. Something like that. What the hell is this? Okay, so rows less than 4 millimeters and faces with the same area. Delete. And reason that this object will be bolted very tight. It's not a problem to delete all those holes when we need only a stiffness, not a stress analysis. If we do stress analysis, as I said previously, unfortunately, we need much more details from the parts. If we need only stiffness, we can do it this way. And for the CNC machine, stress are not very important, because if our CNC will have very big stress, it will not have proper stiffness, so it will not work proper. So all deformation must be very small, and as a result will be small and stress. In different parts. Okay. So, like that. We have couple of objects that we need to simplify, and we need to simplify shaft. Let's do it. component open. We don't need this field, and we don't need this. Nope, we can do this way. Okay, we'll do it's in another way. About 20 minutes and we will have result. And if someone thinks that rate and mesh for those geometry with those number of details and problems will spend less time, geometry you can find and you can do it and you can prove it. So open components. Okay. I remember deleting this face. Deleting this face. And deleting those face. Dance. Just a moment. I know that you want to eat, but please have patience. We already almost finished. This Russia sending shell to our city. Very interesting. Is it heard on the mic? But maybe not heard because I had done some preferences for decrease the number of number of English noise. Yep. Noise removal is very good, especially when shell explode not really near my house. something like that, and now we almost finished. So bumps here. Something like that and something like that. So we create and please say yeah, hooray! They change all four objects. Just a moment, we have some problem here. No, you don't let this. Okay, let's select additional object. Delete. Okay. Oh. Yeah. Okay. And this small problem will give us mesh. So we need to fix them. Or we will get errors and we need to fix them after we get errors. Component, open component. Yep. Let's delete everything that we don't need. Hide others. And delete them. And now maybe more simple way is to create new geometry based on this. In reason that we have a lot of mistakes from modeling. So let's do something like that. Okay. It's not very important, so we choose warehouse project. Yeah. Something like that. Okay, this body hide. And oh, Okay. Something like that. Almost perfect. Delete them. Ideal solution. So, something like component, open component. Let's do the same. Create project. This one, this one, this, 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 and this. Okay. Nope. This one we need to hide. No, 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 no. We don't need this one. Ouch! No, 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 no. I'm an idiot. Just a moment. No, we don't need a project. We need simple hide. All this body. We need pull. And for example, 20 millimeters. Okay. Almost ideal, as I said previously. Yep. And the last, as I see, the last of the last. This could be the only one. Oh no. We have here two objects. Okay, okay, okay. Let's do it with other way. We will delete small geometry. So what should we do? We need to choose this object. We need to choose this object. We need to choose something like this and say face with the same area. Understand. No, it's not the last part, but today. Something like that. Nope. We have hole. Okay. Okay. And here our last object, last component, last part. Let's do it by this way. Bingo. Oh, okay. And have a look here. Yeah. We have very simple geometry. It doesn't have extra object. So let's close. It will save. And now we can create a mechanical model with mesh. We are working. Which says that we are starting mechanical and inputting our geometry. And we need to spend some time for that. While it's open, we can see how mesh have all details. Just in moment. Open, please. Please open. Maybe it was a bad idea to close Discovery. Start Discovery to save geometry format that we need. Yeah, we start transferring. Okay, we start Discovery and we start transferring. Here is our model. And we will create a mesh by default for this time. About for this where we get the first result, I will stop this stream, and later, if the stream will have interest, I will repeat working with this project on a live. I will create a better mesh with better quality, with better sizing, and so. And we talk much more about some questions with preferences in solution. Yeah, we have big problem with our beam on portal. It was huge problem in previous version, we Ansys critical show this part. In most cases, I think that we also can't create automatic mesh, but I think a couple steps will help in creating mesh for this part. And you already improve all elements. Please show us result. Show result to me, please. Please. I want to see it. What did you do and did you do something? Please. If you want to try to work in CFD, in computational mechanics, in finite element analysis, you need a lot of patience. A lot of patience. Because when CAD designer, mechanical designer, CAD user say computer work not very well, freeze, and I need to spend a lot of time, about couple minutes to wait the result, finite element engineer, CFD engineer will laugh and say couple minutes. Yesterday I have very small project. It solved only by 3 days. Something like that. Different scale of time. Nah, I think we will not get here mesh on this part. On other part, yes. On this part, no, because this part are very thin. It's straight, and that's a problem. We can create sweep mesh, but we must say that we need a sweep mesh here. So give a mesh, give a mesh, give a mesh, show a mesh, show result of meshing, show meshing result. Different way to say the same sentences. And where we have okay, what we can say. First of all, I don't know where this beam and where the rail. I forgot them, maybe, but it was, so we need to check them. But about meshing, we create mesh, and as we see, we doesn't have mesh only in one part. All other parts have mesh, and we doesn't have mesh in the part. Yep, it's something what we think that we have. For example, here we have look like of mesh of this part, and this is how those geometry look previously. You can see a lot of small mirrors on all places, and it doesn't give any accuracy and adequate to our result, because we can get it in other way. Okay, what should we do here? Where it is? Here. To get all results. Something is done. I doesn't see here some object. I doesn't see in all others. Okay. Let's hide all other bodies and we will work only with this. We will create mesh of this object, not automatic, but sweep, and source target automatic. It's not a problem. Okay, sweep number 50. For example, also we create sizing on those places, for example, 2 millimeters. And let's try to generate mesh on selected body. Yep, I know that you want to eat later. Yeah, as you see, we have filed mesh in reasons that it's not very good quality. Why it's not very good quality? Why we have here such big elements? Just a moment, face sizing. Oh, 70 millimeters, sorry. I say 2 millimeters. Generate mesh. Maybe 2 millimeters is too small. Just a moment. Preview surface mesh. I understand. Just a moment. Let's change to 5 millimeters. Nope. Let's change automatic source, manual source to this one. Generate mesh and select the body. Quality check. Let's first of all say no and see what we will get here. Why you don't like this mesh? Show me the mesh. Oh, I see. This is normal mesh, but for some reason he thinks that we have problem elements. In this case, it's not, but the size of this edge and this edge are too big difference in ratio. So let's 100, for example. Also, we can say something like that. Mapped mesh, no. Just a moment, I will try. So, generate mesh. Stop. Mesh quality check. Yes, errors. We will turn preferences to default settings. And see that is no problem. It's much, but we have a problem. And it doesn't show face meshing. Let's do this way. It can be a problem with which we try to heal. It was here. If mesh are not created for now, we do some improvements. I forgot about this and problem. Yeah, it doesn't create. Okay, geometry model, virtual topology, and something like that. Okay. Suppress. Sorry. Generate mesh on selected body. Mesh failed. It's creepy and tricky problem. Maybe I need to rest and only then repeat. I don't do anything, something without showing, but maybe I need a rest. Yep. Shit happens. I know. We'll do some changes. So, CNC Mosquito, save, first of all. Uh, yep, almost already. We will soon. As soon as I end, as soon as you eat. Not as. Will you eat? You will eat. Yeah. As soon I will end, as soon you will eat. Mm. So here we have both beam and both rail. And here we doesn't have one beam and both rail. Ouch. Very interesting. Okay. Shit happens. So, first of all, repair merge phase. No, you don't want. That's a problem. Okay, let's take a look to this. Okay, here we have. Here it doesn't have. Yeah, am I right? Hmm. Yeah, we need to do much more here. Okay, additional. Here we have Melvin. Okay, and now And now we need to slice it into number of objects and work with a different but for sending each place which number of faces I give problem. So maybe we will stop here. Fortunately, I don't create analysis as I promised, but I do what I can. So if it was interesting to you, please write a comment about that, and I go to feed my cat, my FEA assistant. So see you later.